Welcome to the deep dive. Today we're skipping past the prepared statements, the corporate gloss,
Right.
and we're digging straight into the real heart of the recent Q3 earnings call, the
Really?
Q&A, the back and forth with investors and analysts.
Exactly, because that's where you really see the strategy tested, where the clarity emerges.
So what's our mission today?
We're aiming to unpack, really synthesize the key things that came out under pressure. I see three main pillars. First, the timeline for actual unsupervised autonomy, it seems surprisingly close.
Okay.
Second, the AI hardware, specifically this new AI 5 chip and the whole vertical integration philosophy behind it.
Right.
And third, maybe the biggest hurdle, the sheer manufacturing challenge of building Optimus, the humanoid robot, at scale.
Okay, let's jump into that first one then. Autonomy. It always felt a bit like just around the corner, but the Q&A, it felt different this time, more concrete.
Yeah, the metrics were definitely harder. The biggest headline, I think, was the timeline they gave for pulling the safety drivers.
In Austin, right?
Yeah, specifically Austin. They said they expect to have no human safety drivers in, and these were their words, large parts of Austin within just a few months, basically
Yeah.
the end of the year.
Wow, okay. That's a huge step. That signals real confidence in the current system.
It really does. And they backed it up with some numbers. For their internal fleet in Austin, they've already logged over 250,000 miles with no one actually in the driver's seat.
250,000 miles, just pure robot driving in one city.
Exactly. And then you look at the Bay Area, where they still need someone in the car because of regulations.
Right.
They've crossed 1 million miles there. But the really massive number, the one feeding the learning loop, is the supervised FSD usage by customers. 6 billion miles globally.
6 billion. That's
Yeah.
just a staggering amount of data.
It's unparalleled. That's the critical pool, informing every little tweak and improvement.
So the data is flowing. But what about getting into new cities? They mentioned expanding, right?
Yeah, the goal is 8 to 10 metro areas by the end of the year. They specifically mentioned Nevada, Florida, Arizona as places they're targeting, but it all hinges on regulatory approvals, obviously.
But there was something interesting about how they plan to expand, even if they get the approvals. This sort of paranoid strategy.
Yeah, paranoid might be the right word. It's basically adding their own safety layer on top of whatever the regulators require.
How so?
Even if a state says, okay, you're approved, go driverless, they still plan to put a safety driver or at least an occupant in the car for about 3 months in any new market.
Okay, but why? If they don't legally need to.
It's not about data collection at that point. It's about finding the weird stuff, the unexpected peculiarities of that specific city. Is there a bizarre intersection, a type of road marking they haven't seen? It's a final check before they really commit to unsupervised driving there.
That makes sense. Better safe than sorry, especially with something like this. Okay, let's shift to the software itself. V14, that's the big one.
Yeah, the foundational rewrite.
And they gave a warning, didn't they? That the first release might be a bit rough.
They use the word jerky. Advise people maybe wait for V14.10.2 if they want a smoother ride.
So why release something jerky? Why not wait until it's perfect?
Well, it suggests this isn't just tweaking code, it's a fundamental rebuild. Like, they're moving away from the old system, lots of human rules, map dependency towards something that's pure end-to-end vision,
Yeah.
AI figuring it out directly from the cameras.
Okay.
And when you do that, when you rip out the old foundation and put in new logic, the first priority has to be safety. Just don't crash.
Right. Survival first.
Exactly. Comfort, like smooth braking or perfect lane centering, that comes second. You have to kind of train that back in iteratively. That's why it's jerky at first.
Okay, that clarifies the trade-off. It's the messiness you get with a real ground-up redesign.
Yeah.
What about people still on the older hardware 3? Are they left behind?
They addressed that. They said a V14 Lite version is planned for HW3 cars, expected around Q2 next year.
Light, meaning fewer features.
Presumably, HW3 just doesn't have the processing power for the full V14 stack. But they did emphasize taking care of those early adopters, mentioned the FSD transfer offers and stuff. The key thing coming, though, for all versions eventually, is reasoning.
Reasoning, that sounds significant. What does that actually mean for the car's behavior?
It's the difference between just reacting to the road and actually, planning ahead, thinking.
So not just following the GPS route.
Right. It allows for higher level tasks. They gave an example. You're going somewhere, the parking lot is packed. A reasoning system wouldn't just drive around endlessly. It might think, okay, I should drop the passenger off right at the entrance first, and then I'll go find a spot way over there. It optimizes for the person's convenience.
Ah, okay. Like a smart chauffeur, not just a driver. When is that expected?
End of the year, they said. Maybe V14.3 or 14.4.
Interesting. Okay, let's talk about the hardware powering all this.
Yeah.
The AI5 chip. The performance claims were pretty eye-popping.
Oh, yeah. They're projecting anywhere from 10x to potentially 40x improvement over the current AI4 chip, depending on the metric. That's a massive jump.
How are they achieving that? Is it just Moore's Law or something else?
It seems like it's more about the design philosophy. They're calling it radical simplicity.
Okay.
And they're having it made by both Samsung in Texas and TSMC in Arizona. But the key, they claim, is that because they own the whole software stack, they could actually delete core components you'd normally find on an AI chip.
Delete components, like
the traditional GPU,
Yeah.
for one, and even the image signal processor, the ISP.
Wait, the ISP, isn't that crucial for cleaning up the raw camera data before the AI even sees it? How do you just delete that?
That's the vertical integration argument. Because they control the cameras and the software and the chip, they don't need a general-purpose ISP that works with any camera. They can bake the specific image processing needed for their cameras directly into the custom logic of the AI5 chip itself.
Ah, so it's hyper-optimized just for their system.
Exactly, which is how they claim they can get these, frankly, incredible efficiency numbers. Best performance per watt in the industry, maybe 2-3 times better. And performance per dollar, maybe 10 times better.
And that efficiency plays into their bigger strategy, right?
Yeah.
Making more chips than they need for the cars.
Yep. They explicitly said the goal is an oversupply. The extra chips, they go straight into their own data centers for training the AI models. It's a completely closed loop.
Build the tools. To build the tools, essentially.
Pretty much. Eliminates bottlenecks, ensures they have the computing power they need internally.
Okay, let's pivot to the other major hardware challenge. Optimus, the robot. We hear stories about them walking around HQ.
Yeah, guiding visitors to meetings, apparently walking around 24/7.
But the Q&A really zeroed in on one specific, massive engineering problem.
The hand and forearm. Overwhelmingly. They called it an incredibly difficult engineering challenge.
More difficult than the rest of the robot.
That's what they said. From an electromechanical standpoint, designing and building the hand and forearm is more complex than everything else combined.
Wow. Is that about the mechanics, like fitting all the little motors in? Or is it the control software, the programming?
They emphasize the electromechanical side. Think about the human hand. The dexterity, the sensitivity, the compact packaging. Replicating that requires incredibly specialized actuators, sensors, stuff that you can't just buy off the shelf at the right performance or cost.
So there's no existing supply chain for robot hands like this?
Basically, no. Which is why the Optimus V3 prototype is so important.
Right.
That's expected Q1 next year, February or March. That'll be our first real look at how they're tackling this hand problem.
And the goal isn't just a few prototypes. They're talking vehicle-level volumes, right?
Millions per year. That's the ambition, which loops right back to that supply chain issue.
They have to build it themselves.
Deep vertical integration, they said, because there is no supply chain for many of these specialized humanoid robot components. They have to design and manufacture things way down the chain actuators, maybe even custom battery cells because the market just doesn't exist yet.
This scale.
Yeah.
Building potentially millions of humanoid robots. The CEO called it a robot army. That actually led to a discussion about corporate control, didn't it? Kind of a strange turn.
It was interesting. The argument was that to pursue something this massive, this risky, this long-term building the robot army requires stable leadership with strong influence.
Meaning voting control.
Yeah, he mentioned maintaining something around the mid-20s in voting control. The concern expressed was that without it, proxy advisory firms, he specifically called out ISS and Glass Lewis, might recommend changes or even ousting leadership before this long-term bet can pay off. He framed it as needing control to prevent corporate terrorists, his words, from derailing the vision.
So, linking the engineering challenge directly to shareholder structure. Okay. Let's bring it back to cars for a moment. This newfound confidence in self-driving, it seems to be unlocking faster production plants.
Absolutely. Now that they feel they have clarity on getting to unsupervised FSD, the message was expand production as fast as possible.
How fast?
The aspirational goal is hitting an annualized run rate of 3 million vehicles within the next 24 months. Huge number. Of course, contingent on the supply chain keeping up.
And this includes that new vehicle platform, the one designed purely for autonomy.
Right, the one codenamed Cybercab. They said production for that starts Q2 next year. And it's really optimized differently. No steering wheel, no pedals.
Really? None at all.
None. Designed purely for autonomy. The main goal isn't speed or handling, it's minimizing the fully considered cost per mile of operation. Think reliability, low maintenance, efficiency.
So what do they think will make people actually want a car like that? What's the big draw?
It's almost funny how simple they made it sound. The killer app. Being able to text while you're in the car. Seriously. Texting.
That was the argument. Once it's truly safe and unsupervised, the ability to get your commute time back for work, emails, calls, entertainment, whatever, becomes the main driver. They think that demand will be so strong they won't even need to cut margins much, despite aiming for huge volumes.
Reclaiming commute time. A very human angle. Okay, quick detour into energy storage. That came up too. Still strong demand.
Very strong, yeah. Both Megapack and Powerwall demand looking good into next year. But there's a new factor boosting Megapack specifically.
Which is?
The AI boom. They're seeing remarkable growth from hyperscalers and utilities buying Megapacks. Why? To stabilize the grid and provide reliable power for all these massive new AI data centers going up.
The energy demands of AI are creating demand for energy storage. Makes sense.
Exactly. And on the residential side, they mentioned a surge in U.S. solar demand thanks to policy changes, and their own U.S.-made solar panels from the Buffalo factory start shipping Q1 next year. Also a new solar lease product. Got it. One final clarification point that came up. The difference between the AI work happening inside Tesla and the stuff at XAI, like Grok.
Right. They made a clear distinction. They're different kinds of AI. Grok at XAI is what they called a giant beast of a model. It's focused on artificial general intelligence, AGI. It's huge, way too big and power-hungry to run in a car.
So Tesla's AI is different how?
Tesla's focus is on what they termed highest intelligence density. Basically getting the most intelligence per gigabyte of model size. Their models have to be much smaller, maybe only 5% the size of Grok, because they have to run efficiently on the AI-4 computer that's actually in the car.
So specialized, super efficient AI for the car's needs.
Exactly. But Grok isn't totally separate. They see it as complementary. It could be used for things like better voice recognition in the car or generating the voice for Optimus, stuff like that. Things that don't need to run locally on the car's chip second by second.
Okay, so wrapping this all up, what's the big picture takeaway for you from this Q&A deep dive?
For me, it's this relentless focus on enabling scale. Yes, the AI software is key, the V14 rewrite, the AI5 chip. But underlying all of it is this drive towards manufacturing capability, the vertical integration, the willingness to build the supply chain themselves.
Because the existing one just can't handle millions of robots or these specialized cars.
Precisely. It suggests the ultimate core competency they're building isn't just software, it's the actual wherewithal to mass produce these incredibly complex machines.
And there was that one final kind of mind-bending idea about what all this could lead to, connecting back to the AI5 chip in the cars themselves.
Right. The distributed inference fleet. That was fascinating. It connects the oversupply strategy for AI5 with the sheer number of vehicles they plan to build.
Explain that again. Millions of parked cars becoming a supercomputer.
Kind of, yeah. The idea hinted at was if you have millions, eventually maybe 100 million vehicles out there with these powerful, efficient AI chips, when those cars aren't driving, they're just parked. They could potentially form a giant distributed inference fleet. Each car contributes a bit of computing power. Add it all up globally, and you could have, say, 100 gigawatts of high-performance AI inference capability.
That's a staggering amount of compute power.
It is. And the kicker, the power delivery and the cooling systems for those chips are already built into the cars. They're already paid for, already maintained as part of the vehicle. It turns the entire customer fleet into this massive, potentially monetizable computational asset.
Wow. So the manufacturing isn't just about building cars or robots to sell. It's about building the physical infrastructure for a whole new kind of distributed computing. That is definitely something to chew on.
It certainly broadens the strategic horizon, doesn't it?
It really does. Well, thank you for walking us through all that detail. Fascinating stuff.
Always a pleasure.
And thank you for joining us on the Deep Dive. We'll catch you next time.